Hey guys, I hope this video finds you safe at home. I hope you are keeping yourself occupied and haven't been too bored. Anyway, this is new material. It's about density, and it is much easier than what it looks like. And you could probably do this without a video. But I kind of missed talking to you guys, and maybe you missed hearing my voice. So I figured I'd just go ahead and do a video. So at the end of this, we're going to figure out how to model real world situations involving I almost said destiny. Density. So density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. And you've seen some of these problems in your science, in some science classes. So the formula again, and I also have this in the document that's included on the with this Google classroom activity. So density equals mass over volume. And population density is population divided by area. So, like I said, these problems are very simple because usually they give you the area and the volume in the problem. But then sometimes they don't. And I think I took out most of the problems that had weird shapes that since we have not done the volume and area sections. But the other ones you should be able to do. I included this review of area on this also, and you can see the triangle is 1/2 base times height, rectangle base times height. A parallelogram is also base times height. And remember, I have said quite a few times that the height is perpendicular to the base. And that's the same, that is true also in a triangle. Now, there's a rhombus, kite, and trapezoid formulas down there. I'm sure you didn't need them unless I just missed a problem and didn't take it out before I assign these sheets. But there they are, and they're useful. Area of a circle. Pi r squared, right? So, not that I think that there's going to be anything that has you doing area in a circle, but just in case. In volume, you have the formula for a prism, length times width times height. Length times width times height. A cube is the same, side times side times side. And a cylinder is just, because it has a round base, you're getting this pi r squared times height instead. Okay, and there's the h, but I'll write it here too because I put that volume in the wrong spot. Kind of took away from the h, so we'll write it over here. Okay, so there you have that. So let's look at some problems. Okay, so find the approximate population density. Burlington, Vermont has an area of 160 kilometers squared, and that's what that 2 is right there. It's just a squared kilometers squared. I didn't notice that earlier. And a population of 109,000 people. What's the approximate population density? So density, again, is population divided by area. And so this is simply 109,000 divided by 160, which gives us 681 people per square kilometer. Now, the next one doesn't give us area. Okay, it gives us the population. But we have to find the area. And we can just find that the area of both of these shapes. So shape 1 is simply length times width. Now notice on here that these guys go by 2s. 20, 40, 60, 80. Okay, so the length is, let's see, 120, 40, 60 is 160. And the length is 40, which gives me 640. How about 6,400? That's probably better, isn't it? And then shape 2 is the triangle. So I have area equals 1/2 base times height. So the base again is 40. And the height again is 160. Which gives me a total of what, 3,200. So 64 and 32 is 00456 9,600. So my population density is 626,000 divided by 9,600, which gives me a population density of 65 people per square mile. Per square, this was miles, right? Yep, 1 mile per square mile. Okay? So if you can picture a square, it's a mile on every side, 65 people, the average that lives in that square. So let's look at example number 2. So why don't you pause here and see if you can do this by yourself, and then we'll, wait, did I forget to put the, I forgot to put the figure in here, or let me make sure. Okay, well, let's forget it. Let me tell you that the area of Chicago is 200 square miles. Okay, so now see if you can do this problem and then turn me back on and see if you did it right. Okay, you should have gotten 13,600 people per square mile. And if you think about this, this is in Chicago, right? That's a big city. That's a lot of people. Here we just talked about that 1 square mile only having 65 people living in it. And now we're talking about a square mile having 13,600 people living in it. That's crazy. Crazy. So let's look at the next one on the next page. Okay, these are more like your science problem when we're calculating measures of energy. So BTU units, British thermal units, are units of energy, and it's approximately the amount of energy needed to increase the temperature of 1 pound of water by 1 degree Fahrenheit. So we talk about BTUs per unit of volume. So a spherical tank is filled with gas, and it has the dimensions that follows. When the tank is filled with natural gas, it provides 116,151 BTUs. Find the number of BTUs produced by 1 cubic foot of glass. Round to the nearest BTU. Well, one of the things I did not talk about was volume of a sphere. Okay, so volume of a sphere is simply 4/3 pi r cubed. And it's easy to remember that a volume of a sphere gets a cube because we think volume is 3 different dimensions that we're measuring. So this is simply 4/3 times pi times 3 cubed. And that is going to give us 36 pi. And I'm just going to leave it in pi, okay? All right, so now we're going to say BTUs for 1 cubic foot of the gas equals BTUs in the tank, BTUs in tank over volume. Okay, so the BTUs in the tank is 116,151, and the volume is 36 pi. And you could put that in a number. I just didn't have a calculator handy, so that's why I left it as pi. And then when you divide that, you get about 1,027 BTUs. Now, if we do the same thing with part B, and we do kerosene, we get 114,206,000 over 36 pi, which gives us 1,027 BTUs. Whoops. I'm sorry, I was looking at the wrong answer. I was like, how in the world did that end up the same number? It can't possibly be right. So anyway, it's 9,803 BTUs. So the next question says, which fuel has a higher energy density? So which one of those is more dense than the other one? And yes, you're right. Kerosene. Okay. Okay. How many? I don't think I have too many more examples. Colorado has a population. Its territory can be modeled by a rectangle. Find the approximate population density of Colorado. Okay, so density equals 5,268,367. And the area, of course, is 280 times 380. Now, if you just did that in your calculator, you got to be careful. Make sure you put parentheses around the bottom. I'm not going to do that. I'm just going to rewrite this with the area below it when I look at my book and find it, maybe, because like I said, I don't have a calculator handy. Oh, there it is. 10, and I don't have you guys here to do it for me. So it gives me 106,400 for the area, which is about 50 people per square mile. Okay. And let's see. Example 5 says a fuel tank has a volume of 32 gallons. When filled with biodiesel, it provides how many BTUs in 1 gallon? So BTUs per 1 gallon is going to be 4 billion divided by 32 gallons, which gives us 125 BTUs per gallon. Okay. Example 6 is a little different. It says Manila has one of the highest population densities in the world. Now remember, density equals population over area. Okay, and so the density is 111,002. The population is 1,652,171. And how large is it? So it wants us to find the area. Okay, so that's our x. So I'm going to rewrite this using x. 1,652,171. Okay, so the first thing I need to do is move the x over, and we had to do these kind of problems in trig. Move that x over first, and then I'm going to divide by 111,002. And I get the area equals 14.9 miles squared. And that's it. That's all I've got. I hope those problems help. If you have any questions, just email me, and we can figure it out together. Again, stay safe, kiddos. Know that I miss you. Staying at home this long isn't all it's cracked up to be. So keep a smile on your face, and we will talk soon. Bye.